Hello everyone, this is my final project to robotics and controls. It is a dynamic control system for a 3 degree of freedom robotic arm. It'll allow it to move to a target trajectory while balancing a frictionless object on its end. Um, on the top right, we have the simulation model with the object being this blue cube. It is there's no friction acting upon it, so it could essentially be a rolling ball balancing on its end. On the bottom right, we have the scopes to the joint positions, and we'll start this model right now and give the model a side profile. Right. In the bottom left, we have the initial inputs of the desired final positions and the desired amount of time you want the system to take to move to that position. In the trajectory generation block, we perform inverse kinematics to determine the joint angles of the final position, and we use higher order polynomials to create coefficients, which will be used to generate the trajectories of the velocities, positions, and accelerations over time. The generated trajectories are then compared with the actual values of the system, which will create the error for us, the error of the system. That error would be sent over to the mass manipulated dynamic block, which would be used to calculate how much torque we need to move the system. There are two manipulated dynamic blocks because this one accounts for the mass effects, and the top left accounts for centripetal, Coriolis, and gravitational forces that will be acting on the system. The two torques are then summated and sent back to the simulation model. Here we have the simulation model. Let's open it up. Here we have each joint. This is one. This is another, and it continues downward from there. We have torque inputs and a disturbance input, and we have sensors on each joint as well as the position of the frictionless object. So on the bottom left here, we have a few blocks to input disturbances. Now that our system is at a steady state, we can apply some disturbances and see how the system reacts. You can see that the block actually, the joint position actually follows along as the block is being pushed to realign it to the center of the joint. So let's pause it. Let's stop the system and check the positions. You can see that the first joint is able to follow the trajectory pretty well compared to the second and third joint, which are more greatly affected by the moving mass. So this is able to accomplish this task in roughly slightly under 20 seconds, and I hope to improve it in the near future. Thank you for taking the time to view this video.